now let's do logistic regression, sir. Logistic regression is basically inputs, weights, or output. The input दिया, each input is attached with a weight, and then the model figures out and gives you certain output. Either happy, sad, like this example. ठीक है तो 73 something slides are. Let's just get it done with. Supervised learning. So this point pe I'm assuming like everyone knows supervised learning. ठीक है. Learning where data is labeled and the motivation is to classify or predict the value. तो basically what it means is the machine को ना train करने के लिए data लगता है. ठीक है, कोई भी मॉडल को ट्रेन करने के लिए डेटा लगता है और मॉडल को ट्रेन करने के लिए एल्गोरिथम लगता है. The data is fed into the algorithm makes the model. So in supervised learning, the data that is being provided to the algorithm is basically labeled. Dogs and cats ka example, the dogs ke photos have been labeled as dogs and cats ke photos have been labeled as cats. That the algorithm simply needs to differentiate between them and then make the model. Model pe naye outputs, inputs do, and then the model can predict based on the testing set ki if it's a dog or a cat. Now there are types of supervised learning. As supervised learning is used to classify something or predict a value, जैसे अपने देखा dog और cat को predict कर रहे थे, the previous example that I gave. Naturally, there are two types of algorithms for supervised learning: classification models and regression models. Classification is something that we already know, data mining में भी किया. Classification is basically let's say there are two classes, dogs and cats. So those are two classes and we can separate them from each other, and the model can tell us कि depending on the input वो कौन सी class का है, dog है या cat है. Like input that is being given, the image in this case, it is a dog or is it a cat. What's a regression model? So देखा classification में जैसे you saw that we could use images, we could use numeric values, we could use like predicting a transaction fraud. So classification, the data type is not really as the constraint with us. ठीक है, any type of data can be classified. Boys and girls can be classified. A fraud or a non-fraud can be classified. A scam website and a non-scam website can be classified. But in regression model, the data is pretty much restricted to a numerical value. ठीक है, predicting the sale price of a house, predicting the stock के prices, predicting what time will the sun set or what something. So it is all numerical values. ठीक है, regression model. ठीक है, what is logistic regression? ठीक है, logistic regression is an example of supervised learning. Supervised learning is क्या? Data has been labeled, ठीक है, before the training. So that supervised learning, logistic regression is an example of supervised learning. It is used to calculate or predict the probability of a binary yes or no event. ठीक है, तो the output of a logistic regression model can be numeric, binary yes or no, that is, it can be a 1 or a 0. An example of logistic regression could be applying machine learning to determine if a person is likely to be infected with COVID-19 or not. तो ये भी binary output आएगा, yes या no आएगा, 1 या 0 आएगा. Since we have two possible outcomes to this question, yes they are infected or no they are not infected, this is a binary classification. तो ये binary classifier हो गया. ठीक है, the output that is the target or the dependent variable जब हम naive bias में किए थे, 1 या 0 है, yes या no है. ठीक है, बाइनरी है, दो ही है, दोनों में से कोई एक ही आ सकता है. ठीक है, so in this example the probability of person being infected with COVID-19 could be based on a viral load of and symptoms and the presence of antibodies, etc. Viral load, symptoms, antibodies would be our factors, that is independent variables, which would influence our outcome, that is dependent variable. तो जो अपन ने attributes देखे ना अब तक, जैसे वायरल लोड, सिम्टम्स, एंटीबॉडीज, इनके वैल्यूज जैसे जैसे चेंज हो गए ना, वैसे अपना डिपेंडेंट वेरिएबल चेंज होगा, आउटपुट चेंज होगा. ऐसा वाइस वर्सा नहीं कर सकते, मतलब आउटपुट चेंज किया तो इनपुट चेंज होगा. दैट मेक जीरो सेंस. तो येस की जगह पे क्या लिखेगा आगे? बट यू कैन से दैट वायरल लोड वॉज हाई, सिम्टम्स वर दीज, एंटीबॉडीज इन योर बॉडी वर दीज, एंड डिपेंडिंग ऑन दैट वी कैन फॉर्मुलेट कि कोविड था या नहीं था, या है या नहीं है, होने वाला है या नहीं होने वाला. ठीक है, डिपेंडिंग ऑन व्हाट द objective of the model is. ठीक है, तो what is logistic regression? Again, logistic regression aims to solve classification problems. Again, classification is when you are able to divide the data set into two or more different classes. ठीक है? It does this by predicting categorical outcomes, unlike linear regression that predicts continuous outcomes. तो categorical outcomes क्या होता है? Basically, ठीक है, पहले linear समझ लेते हैं. Linear regression that predicts continuous outcomes. Continuous मतलब that is a series of values. ठीक है, but categorical outcomes क्या है? ऐसे fraud mails हो गए. Fraud mail is a category. So the logistic regression model can predict कि this mail is a fraud mail depending upon the supervised learning था. तो you have already given examples of fraud mails, right? But linear can't do that. Linear में how will you make how will you like distinguish? ठीक है, but categorical, because logistic regression is categorical based, you can get that done. ठीक है, you can get the 1 or 0 wala output if it is a fraud mail or not. In the simplest case, there are two outcomes which are binomial, binary. An example is predicting if a picture given to the model is male or a female. Other cases have more than two outcomes. To classify in this case, it is commonly called multinomial. तो एक binomial हुआ, ठीक है, और एक multinomial हुआ. Multinomial मतलब more than two outcomes. ठीक है, जैसे we have seen examples. Let's say you have to predict the weather for the day. ठीक है, iris level I didn't really understand. 3 different species, okay. Let's say you have to predict the weather for the day. It can be sunny, it can be rainy, or it can be snowing. ठीक है, so that is a multinomial outcome of the logistic regression model. ठीक है, here we will be using basic logistic regression to predict a binomial variable. This means it has only two possible outcomes. This is what we're going to study आगे, I guess. Where to use logistic regression? Logistic regression can be used to solve classification problems. And the most common use is binary logistic regression. Binary logistic regression is again two outcomes. Binary पढ़ लिया मतलब 1 और 0 आना ही चाहिए दिमाग में, naturally आता है. Whether the outcome is binary, yes or no. In the real world, you can see logistic regression applied across multiple areas and fields. ठीक है, हर जगह, from if you are hungry, do you want to eat a pizza or not, to do you want to go to college or not, or do you want to skip the breakfast or not, whatever, every decision that you take in your day-to-day life is a binary decision, yes या no है. There's no like middle कि नहीं ये दोनों में से कुछ नहीं करना. So let's say like normal examples that we can write in the exam. So healthcare में logistic regression can be used to predict if a tumor is likely small or big. ठीक है, benign है या malignant है. ठीक है, in the financial industry, logistic regression can be used to predict if a transaction is fraudulent or not. ठीक है, in marketing, logistic regression can be used to predict if target audience will respond or not. click through rates होते हैं यूट्यूब्स में, Amazon में click through rates होता है. So it's basically if the audience that you're showing a content to, will they respond or not to that content, is what is where logistic regression can be used. Are there other use cases for logistic regression aside binary logistic regression? Yes, obviously. There are two other types of logistic regression that depend upon number of predicted outcomes. Let's see. ये same था. ठीक है. Logistic regression. Logistic regression is one of the most popular machine learning algorithms. ठीक है. SVM भी popular है. But yes, which comes under the supervised learning techniques. SVM is not supervised. It is used for predicting the categorical dependent variable used as a given set of independent variables. वो ही हुआ, मतलब you have attributes है, and then you have to figure out that like independent variables, and you have to throw out a dependent variable as the output. Logistic regression predicts the output of categorical dependent data. Same चीज़ घुमा फिरा के बोल रहे हैं आप. Therefore, the outcome must be categorical or discrete value. Outcome must be categorical. Either sunny है, raining है, snowing है. A discrete value, yes, no, 1, 0, true, false, etc. आज का एग्जाम पेपर में ही देख लो, car was fast or not, जो भी है. But instead of giving the exact value as 0 and 1, it gives a probabilistic value which lies between 0 and 1. ठीक है, probability के basis पे it is working. It might not all give 0 and 1 ऐसा कि 0 ही है या 1 ही है. ठीक है, it might give something between 0 and 1. The probability of something happening is not completely ऐसा 100% होगा या 100% नहीं होगा. ठीक है. Logistic regression is much similar to linear regression, except that how they are used. Linear regression is used for solving regression problems, while logistic regression is used for solving classification problems. ये तो पहले समझा दिया. In logistic regression, instead of fitting a regression line, we fit an S-shaped logistic function. S-shaped logistic function जब आता है ना, वो sigmoid बोलते हैं उसको, ठीक है, which predicts two maximum values 0 or 1. The curve from the logistic function indicates the likelihood of something such as whether the cells are cancerous or not, a mouse is obese or not. Who the fuck wants to know if a mouse is obese or not, based on its weight, etc. Logistic regression is a significant machine learning algorithm because it has the ability to provide probabilities and classify new data using continuous and discrete data sets. So that is the advantage. देख, पहले तो अपन ना एस कर्व समझ रहे, थोड़ा आगे भी समझने लाइक पीपीटी में आगे होगा ही ऑब्वियसली, बट सो let's say that you have something. The probability of it raining today is not 100%. It might be 80%. There are chances that 80% might rain. So how do you fit it on 0 to 1? So it becomes 0.8. The probability of it raining is 0.8. Okay? It can be 8,000%. The more, so it moves more towards this 1. Okay? What is logistic regression is significant machine learning algorithm because it has the ability to provide probabilities and classify new data using continuous and discrete data sets. तो continuous data sets क्या हुआ, that it is similar. Continuous मतलब पूरा सनी का data तूने साथ में दे दिया, and discrete data sets like even though it belongs to the same data set, it is not of the same attribute. Like attribute is weather, तो सनी का पूरा data is not compulsory. You can provide data for winter or monsoon or something, and then the model can figure out based on the other attributes and the outcome. Logistic regression, though, even if you want to predict sunny, it is not compulsory to provide sirf sunny ka data. You might actually want to provide more data so that it performs better. Okay? Logistic regression can be used to classify observations using different types of data and can easily determine the most effective variables used for classification. वही मैं बोल रहा था. Even if you want to predict if it is going to be sunny, the data set में you don't ऐसा data set में ऐसा compulsory नहीं बस sunny वाले values दे दिए. You should actually give other values also, and then let the logistic regression model decide कि what is the most significant या effective variable used for the classification. ठीक है? This image below shows the logistic function. Sigmoid curve बोलते हैं, S curve. Sigmoid function is what converts the value in the range of 0 to 1. Sigmoid function आ गया देखो. The sigmoid function is a mathematical function used to map predictive values to probabilities. Basically वो तू कुछ भी value दे उसको, it will put it in the range of 0 to 1. ठीक है? 15 लाख दे, 50,000 दे, 50,000 दे, give it like 0, give it like 1, 2, कुछ भी. It will just make sure that the value of that is converted to 0 to 1 के range के बीच में. It maps any real values into another value within the range of 0 and 1. The value of logistic regression must be between 0 and 1, which cannot go beyond this limit, so it forms a curve like S. S-like curve form करता है. The S-form curve is called sigmoid function or the logistic function. Logistic function because logistic regression है, तो logistic function, sigmoid function. So logistic function or sigmoid function basically same shit. Don't get confused. Logistic regression and linear regression are different. Logistic regression में we use the concept of threshold value, which defines the probability of either 0 or 1. तो 0 और 1 जो है ना, उसकी probability को define करने के लिए threshold है. Such as the values above the threshold value tends to 0, and value below threshold value tends to 0. Now, such as the value above the threshold value tends to 1, and the value below, तो तूने threshold set किया. Suppose threshold is 0.5. Anything above 0.5 will naturally tend to 1. It will move towards 1. Anything less than 0.5 will naturally move towards 0, will be more inclined towards 0. Assumptions for logistic regression. The dependent variable must be categorical in nature. ठीक है? Unlike linear regression where the data needs to be numerical, either the data is preferred to be categorical in nature. ठीक है? The factors or the independent variables that influence the outcome are independent of each other. The factors or the independent variables that influence the outcome of are independent of each other. तो मतलब आज सन है और तू आज खेलने जाएगा क्रिकेट, इवन दो यू माइट सी सेंस इन इट, बट फॉर द मॉडल दोज आर इंडिपेंडेंट ऑफ ईच अदर. ठीक है, independent variables combined will give you a dependent answer, but there is no direct correlation that is being established is what they're trying to say. But for a human they can clearly see a correlation. In other words, there is little or no multicollinearity among the independent variables. Okay, these are now talking about independent variables. So obviously there is a connection between the attribute and the target. But if there are like two attributes, if it is raining today and there is let's say if it is raining today and there are no parents at home, ठीक है, then you might wanna not go and play out and stay home and chill. ठीक है, so even though raining today and no parents at home does not have any co-linearity or no correlation between each other, but for the final answer or for the human there is a relation. That is why you're making that choice. And if it is sunny today and there are no parents at home, you might want to go and play out. ठीक है, fairly large sample size is what is important for training. That goes for every machine learning model. जितना ज़्यादा डेटा दोगे which is like different from each other, the better it will be able to recognize. Outliers देना नहीं बोल रहा मैं. So this is the data, fit an iteration. I don't know what this is doing. ठीक है, ट्यूमर साइज. So इधर देख रहे हो स्ट्रेट लाइन फॉर्म हो रहा है, बट टेक्निकली इट्स एन एस कर्व. They will show आगे how is it an S curve. Logistic regression equation. I really don't know if this is like important, but ठीक है, एक बार देख लेते हैं ना क्या फ़र्क पड़ रहा है. So logistic regression equation can be obtained from linear regression equation. The mathematical steps to get logistic regression equations are given below. So there's this equation b0, b1, x1, b2, x2, b3, x3, bn, x1. We know the equation of the straight line can be written as this. In logistic regression, y can be 0 and 1 only. Okay, it is bound to be 0 and 1. So for this, let's divide the above equation by 1 minus y. Y upon 1 minus y, therefore where 0 for y equals 0 and infinity for y equals 1. Because 0 is defined as 0 only and infinity is 1. But we need range between minus infinity to positive infinity. Then take logarithm of the equation, it will become log y upon 1 minus y. ठीक है, y is either 0 or 1, and then the equation for the straight line. ठीक है, I do not know how is he gonna ask this, but yes, थोड़ा ऐसा समझ लो क्या. Types of logistic regression. On the basis of categories, logistic regression can be classified into 3 types. एक होता है binary, एक होता है multinomial, एक होता है ordinal. Now what is binary? Binary as we saw पहले, yes या no, COVID है नहीं है. Multinomial logistic regression is when there are multiple outcomes. COVID है तो कितना है, ज़्यादा है, कम है, बहुत कम है, बहुत ज़्यादा है. That is multinomial. That is like multiple outputs. ठीक है, we can have multiple outcomes. Say if we build our original example to predict whether someone may have the flu, an allergy, a cold or COVID-19. So they have not taken the scale. ठीक है, scale is for ordinal. ठीक है, I mean I gave the ordinal वाला example. But multinomial is basically flu है, allergy है, cold है, COVID है. But ordinal logistic regression is when there is an order to it. ठीक है, that is COVID है तो कितना है, mild है, moderate है, severe है, तो that is ordinal. I believe that every ordinal is a multinomial, but not all multinomial. Not all multinomials can be ordinal, because multinomial का concept is multiple outcomes. Even ordinal has multiple outcomes, just that they are in an ordered fashion and belong to the same group. So yeah, model evaluation. So binary, multinomial, ordinal. ठीक है. Model evaluation. Model evaluation matrix are used to find out the goodness of the fit between model and data, to compare the different models in the context of model selection, and to predict how predictions are expected to be accurate. Model evaluation. Model evaluation matrix are used to find out the goodness of the fit between model and data. तो तेरे पास model है, तेरे पास data है, there obviously needs to be a fit, and the better the fit, it's not like completely अच्छा होना चाहिए. ठीक है, completely अच्छा हो गया तो overfit हो जाएगा ना. So there needs to be a goodness, not loose fit, yeah, and not overfit. ठीक है, तो this is important to predict how predictions are expected to be accurate. Confusion matrix, ठीक है, इसके numerical भी है, I'm assuming, yeah है. A confusion matrix is a summary of prediction results on a classification problem. The number of correct and incorrect predictions is summarized with count values broken down by each class. This is the key to confusion matrix. Confusion matrix shows the ways in which your classification model is confused when it makes a prediction. Basically, it is a diagrammatic representation of all the outputs that a model is gonna give. So दिमाग में बिठा दो. It is a diagrammatic representation of all the outputs that a model is gonna give. Confusion matrix shows the ways in which a classification model is confused when it makes a prediction. It is not always confused, but what they mean by confusion मैं समझाता हूँ. Confusion matrix gives the insight not only into the errors being made by a classifier, but more importantly the type of errors that are being made. It is this breakdown that overcomes the limitation of using classification accuracy alone. Classification accuracy, though we know how accurate the model is. But if it is not accurate, then where the mistake is happening is important to know. बराबर किधर है वो mistake. That is why we use a confusion matrix. तो I'll explain. चलो, let's take our same example. Dog और cats वाला. ठीक है? Positive. ठीक है. Let's take. हाँ. So if it is able to recognize a dog which is a dog, so it is a true positive. बराबर. मॉडल का काम क्या था? To predict if it is a dog or not. And given data set as dogs and cats के images. तो if it is a dog and it predicts that it is a dog, तो true positive है. बराबर क्या? False negative, false positive आएगा अभी. What is false positive? If it detects a cat as a dog, तो false positive हुआ. तो cat था, तूने उसको dog बोल दिया, तो false ही होगा ना. It was supposed to be dog. Now what is false negative? False negative is when it shows a dog as a cat. ठीक है, I'm taking this dog and cat वाला example because it is easier for me to understand using that. अगर वो एक cat को dog बोला तो false positive हुआ. Our model का basic output है कि dog को predict करना है. तो everything is in terms with dogs. Dog है तो true है. Cat dog आया तो false है. अभी false negative क्या है? अगर एक dog को cat बोल दिया तो वो negative हो गया, false negative हो गया. ठीक है. अभी ट्रू नेगेटिव क्या है? अगर उसने एक कैट को कैट बोला तो वो ट्रू नेगेटिव है, बिकॉज इट वॉज अ कैट एंड वॉज सपोज टू बी अ कैट. ठीक है. तो ये कन्फ्यूजन मैट्रिक्स है 2x2 का. ये नाउ इन सब के मेजर्स है. वॉट ऑल कैन यू डिराइव फ्रॉम इट? वी कैन डिराइव पॉजिटिव प्रिडिक्टिव वैल्यूज. पॉजिटिव प्रिडिक्टिव वैल्यूज का फॉर्मूला है, देख लो. मैं फॉर्मूला बोलने के मतलब नहीं है, ऐसा याद नहीं होगा ऐसा बोलूँगा तो. देन देयर इज नेगेटिव प्रेडिक्टिव वैल्यूज. तो दो का तो सेट बन गया, PPV और NPV का. देन देयर सेंसिटिविटी ऑफ द मॉडल, देन देयर स्पेसिफिसिटी ऑफ अ मॉडल, एंड देन देयर इज एक्यूरेसी ऑफ द मॉडल which actually takes in all the possible values, 4 values. ये formulas देख लेना. एंड बेसिकली ये सब में जो नंबर्स आएंगे ना ऑफ द होल डेटा सेट, जस्ट पुट देम इन एंड देन यू विल गेट द आंसर. कुछ ज़्यादा है नहीं. हाउ टू कैलकुलेट अ कन्फ्यूजन मैट्रिक्स? Below is the process for calculating a confusion matrix. You need a test data set or a validation data set with expected outcomes, expected outcome values. Make a prediction for each row in your data set from the expected outcomes and prediction count. The number of correct predictions for each class, the number of incorrect predictions for each class, organized by the class that it was predicted. ये जो मैंने समझाया. These numbers are then organized into a table or a matrix as follows. Expected down the side. Each row of column predicted class. Predicted across the top. Each column of the actual class. ठीक है, ये तो मैंने समझा दिया. The counts of correct and incorrect classification are then filed into the table. The total number of correct predictions for a class goes into the expected row for that class value and the predicted column for that class value. In the same way, the total number of incorrect predictions for the class goes into the expected row for that class value and the predicted column goes into the class value. जो भी डेटा जिधर था वो फीड कर दो. ठीक है. कन्फ्यूजन मैट्रिक्स का एग्जाम्पल लेते हैं. अभी ये डेटा सेट था अपना. एक्सपेक्टेड वॉज मैन man woman man women man woman man woman man, बट द प्रिडिक्शन इज मैन को वुमेन बोल दिया, मैन को मैन बोला दिस इज ट्रू पॉजिटिव, तो ट्रू ट्रू हो गया। वुमेन को वुमेन बोला ये भी ट्रू ट्रू है, मैन को मैन बोला ये भी ट्रू, वुमेन को मैन बोला तो दिस इज अ फॉल्स पॉजिटिव, ठीक है। वुमेन को वुमेन बोला ट्रू ट्रू है, तो accordingly accuracy, suppose the algorithm made 7 of 10 predictions correct, which is an accuracy of 70%, then accuracy equals to total correct predictions upon total predictions made into 100, बराबर 7 करेक्ट निकाला 10 में से, तो accuracy 70% आया। Types of errors, we can determine that by turning out our results into a confusion matrix. First we must calculate the number of correct predictions for each class. Men classified as men 3, women classified as women 4, ठीक है, वो लास्ट ये डेटा सेट में था। Now we can calculate the number of incorrect predictions for each class. Men classified as women 2, women classified as men 1. Now put them in the matrix. Men men true 3, women women true 4, तो ये जो डायगोनल लाइन दिख रहा है these are true predictions। अभी ये वाला डायगोनल रॉन्ग है, men predicted as women 1 था, अच्छा दिस इज वुमेन क्लासिफाइड एज मैन, तो पहले कॉलम देख, women classified as men is 1, men classified as women is 2, बराबर, men classified as women is 2, डाल दिया। Learnings from this data, from this confusion matrix, from the above table we learn that the actual men in the data set is the sum of the values of men column, ठीक है, the actual men in the data set is the sum of the values of the men column, तो टोटल मैन कितने डेटा सेट में 5 है, इज दैट ट्रू, चेक कर लेते हैं, 1 2 3 4 5, बराबर। अकॉर्डिंगली टोटल वुमेन इन द डेटा सेट आर 1 + 4 5, द टोटल एक्चुअल वुमेन डेटा सेट आर बराबर। द करेक्ट वैल्यूज आर ऑर्गेनाइज इन अ डायगोनल लाइन, मैंने बोला ना डायगोनल लाइन में करेक्ट वैल्यूज है 3 और 4, फ्रॉम टॉप लेफ्ट टू बॉटम राइट, टॉप लेफ्ट टू बॉटम राइट। More errors were made by predicting men as a women than women as men, देख ही रहा है वो, ज़्यादा एरर बना था जब men were predicted as women, less errors were when women were predicted as men, one ही था वो। So now comes the concept that we discussed earlier, true positive for correctly predicted event values, false positive for incorrectly predicted event values, true negative for correctly predicted no event values, false negative for incorrectly predicted no event values. Types of wrong predictions. Wrong predictions can again be categorized into false positive, false negative, वो तो देखा अपन ने, this is false negative, false positive. False positive type 1 error, false positive is basically type 1 error when predicting something that doesn't occur, ठीक है, you predicted something that didn't happen only। चलो let's take an example, earthquake। If there's an earthquake and if you predict an earthquake and the earthquake happens, then it is true positive, ठीक है, and if you predicted there is no earthquake and the earthquake did not happen, then it is a true negative, ठीक है, positive because earthquake is happening, negative because earthquake is not happening। Now type 1 error discuss करते हैं, false positive। Let's say you predicted कि earthquake होगा but it never happened or it never occurred, तो it is a false positive, false positive alarm set हो गया। अरे earthquake का एग्जाम्पल दिया, we predict that an earthquake would occur which didn't happen, ठीक है। Now let's take false negative, when we predict that something won't occur but it happens, आपने प्रेडिक्ट किया कि earthquake नहीं होगा but हो गया, तो it is a false negative prediction, that your prediction was negative, it was a false negative but it was meant to be a positive। Usually type 1 errors are considered to not be as critical as type 2 errors। Obviously imagine earthquake का तुम लोग ने false prediction दे दिया कि कोई earthquake होगा but earthquake नहीं हुआ, तो क्या फ़र्क पड़ रहा है, it did not do any harm ना। but if you predicted कि earthquake नहीं होगा और हो गया, so that is more critical ना, कि prediction was कि नहीं होगा but earthquake actually happened, which is more dangerous। So false negatives are more critical to deal with than false positives. Similarly, if you predicted a cancer, you predicted a false positive cancer case. तूने बोल दिया इस बंदे को कैंसर है, they ran the test and नहीं आया. So that is not a problem. नहीं आया तो अच्छा है. But if you predicted कि इस बंदे को कैंसर नहीं है and you did not do any tests on that person and that person died because you made a wrong prediction, then that is important ना, कि वो तो गलत हो गया. The false negatives always get more importance. Now, confusion matrix. A confusion matrix presents a table layout of different outcomes of the prediction and results of classification problems and helps visualize its outcomes. ये तो पता है भाई, कितनी बार सेम चीज़ देखो ना एक्सप्लेन होता है दिमाग में, they're like literally injecting it. It plots a table of all predicted and actual values of the classifier. How to create a 2 by 2 confusion matrix? We can obtain four different combinations from the predicted and actual values of a classifier. Again, true positive, false positive, true negative, false negative. Bhai, literally kitni baar? The number of times our actual positive values are equal to predicted values. I think इस पॉइंट पे सबको पता है, बट हाँ ठीक है, देख लो. So number of times our model actually predicted a positive value which was equal to the predicted the number of times our actual positive values are equal to the predicted positive values, false positive. The number of times our model wrongly predicts negative values as positives. Then the number of times our actual negative values are equal to the predicted negative values, which is this bottom corner. False negatives, which is important, critical to deal with. The number of times our model wrongly predicts negative values as positive. You predict a negative value and it is actually a positive. Confusion matrix. Confusion matrix के metrics. Oh my god. Consider confusion matrix made for a classifier that classifies people based on whether they speak English or Spanish. From the diagram we can see that true positives, that is English speaker 86. They are English speaker and the model predicted कि वो English बोलता है. True negatives 79, मतलब स्पेनिश बोलता है, सही है. It predicted कि वो स्पेनिश बोलेगा और एक्चुअली स्पेनिश बोलता है. False positive, it predicted कि वो स्पेनिश बोलता है बट वो एक्चुअली इंग्लिश बोलता है. बराबर? ओ नो, it predicted कि वो इंग्लिश बोलता है बट वो एक्चुअली स्पेनिश बोलता है. दिस इज एक्चुअल, ऊपर वाला एक्चुअल है. व्हाई डू आई कीप मिसिंग देम? ऊपर वाला एक्चुअल है. इट प्रेडिक्टेड कि वो इंग्लिश बोलता है, ये मशीन का आउटकम है, बट वो एक्चुअली स्पेनिश बोलता है. तो फॉल्स पॉजिटिव. फॉल्स नेगेटिव कि मॉडल प्रेडिक्टेड कि वो स्पेनिश बोलता है बट वो एक्चुअली इंग्लिश बोलता है. ठीक है. कंफ्यूजन मैट्रिक्स. To find how accurate a model is, we use following matrix. Accuracy. The accuracy is used to find the portion of correctly classified values. It tells us how often a classifier is right. It is the sum of all true values divided by total values. Sum of all true values divided by total values. मतलब 86 plus 79, true positives on true negatives upon all of this. True positive, true negative, blah, 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 blah. So 86 plus 79 upon 86 plus 10 plus 79 plus 12. In this case, it is 88.23% of the times the prediction of our model is right. Now, accuracy हो गया. Now precision. Precision is used to calculate the model's ability to classify positive values. ठीक है. It is true positives divided by total number of predictive positive values. ठीक है. Precision tells us how many of the correctly predicted cases actually turned out to be positive. ठीक है. तो precision क्या है? True positive upon true positive plus false positive. तो total positive values, true positive divided by total positives. ठीक है. 86 plus 12, 87.5 times. Precision इतना है. Recall true positive rate TPR. Recall is used to calculate the model's ability to predict positive values. How often does the model predict the correct positive values? It is the true positives divided by the total number of actual positives. True positives divided by total number of actual positives. इधर पहले TP upon FP था, but actual positives, so it would be 86 plus 10, बराबर, तो 89.93%. That is the recall. Example, consider the model TP, TN, FP, FN. I'm assuming that is not what they're gonna give. They'll give us a table like men and women wala, and then we have to make the confusion matrix and then mention the TP, TN, FP, FN, and then find out accuracy and all what they're asking. Now, ये देखो, accuracy of the model is 96, which is insane. Imagine 96% of the times the model is right. Keep थोड़ा ध्यान देना, बहुत interesting है ये. 96% of the times the model is right, which is insane. But it is giving the wrong idea about the result. Think about it, thoda. Our model is saying I can predict sick people 96% of the time. However, it is doing the opposite. This is the requirement of the model. But it is doing the opposite. It is predicting the people who are not sick with 96% accuracy. ठीक है, ट्रू नेगेटिव्स कितने ज़्यादा देख, ट्रू पॉजिटिव शुड हैव बीन मोर ना, दैट इज व्हेन द मॉडल वुड हैव मेकन मोर सेंस. ठीक है. सो what is the problem here? Shouldn't we be measuring the कितने true positives आ रहे हैं, because that is what our model was actually meant for. Because true negatives figure करके क्या करना है? True negatives मेरे को कम आएंगे तो चलेगा, I can actually test them. But if true positives are only less, then what is the whole point? And so I have to do more testing ना. If the model is able to tell me starting में that इतने positive है, then it is better for the whole thing, whole process. This is where we come across dual concept of precision and recall. ठीक है, precision versus recall. Precision tells us how many of the correctly predicted cases actually turned out to be positive. How many of the prediction में से कितने actually positive निकले, that is the precision. ठीक है. This would determine whether a model is reliable or not. More the precision, more it is reliable towards our intent with which we made the model. Recall tells us how many of the actual positive cases were able to predict correctly with a model. Recall tells us how many of the actual positive cases we were able to predict correctly with a model. मतलब 1000 में से if you were able to predict 900, it will tell us that 90% of the time it was correctly predicting. ठीक है. Now let's take an example. वही वाला sick people वाला. Sick people correctly predicted as sick people by the model is 30. Sick healthy people predicted as sick is 30. Sick people predicted as not sick is 10, and healthy people predicted as healthy is 930. ठीक है. Our model का intention was never to figure out कि हाँ तू healthy है या नहीं healthy है. It was to tell us कि you are not healthy. ठीक है. तो precision is 0.5, recall is 0.75. ठीक है. Precision versus recall. 50% of the correctly predictive cases turn out to be positive cases, where 75% of the positive cases were successfully predicted by a model. Precision is used as a useful metric in case where false negative is higher concern than false negatives. False positive is a higher concern than false negative. Precision is important in music or video recommendation system, commerce websites, etc. Wrong results could lead customer to churn and be harmful to the business. It is like अगर तेरे को Amazon पे कुछ दिखा रहा है, ठीक है, it is important you see what your model was supposed to show you. If you see something which your model is not supposed to show you, तू ढूंढ रहा है washing machine, तेरे को बार बार बोल रहा है iPhone ले, what sense does it make? It would actually end up annoying the customer. ठीक है. That is what the point is. देखो जो चाहिए वो दिखना चाहिए ना, जो नहीं चाहिए वो दिख रहा है. It is nice, the accuracy is nice, but मेरे को वो दिखाना जो which I had asked for. That is what precision is. Recall is useful matrix in case where false negatives trumps false positives. Is useful matrix में false negatives. मतलब if the person is healthy, but our model said it is not healthy. So this is where recall is important. Well, it doesn't matter whether we raise in false alarm. वही, if the person is healthy and we say it is not healthy, फर्क नहीं पड़ रहा. अपन चेक कर लेंगे, टेस्ट रन कर लेंगे, मेडिकल ब्लड टेस्ट करवा लेंगे उस बंदे का. ठीक है. Precision versus recall. In practice, when we try to increase the precision of a model, the recall goes down, and vice versa. The F1 score captures both trends in a single value. So precision and recall now are inversely related to each other. If we try to increase precision, recall नीचे जाएगा. If we try to increase recall, precision नीचे जाएगा. F1 score is a harmonic mean of precision and recall. It is like the sweet spot. ठीक है? And so it gives us a combined idea about these two metrics. It is maximum when precision is equal to recall. Precision and recall जितना close to each other होगा ना, F1 score उतना ज़्यादा होगा. And the F1 score, it is a harmonic mean of recall and precision. वो तो समझ गया. It is useful when you need to take both precision and recall into account. ठीक है. F1 score का formula is 2 into precision into recall upon precision plus recall. In this case, our F1 score is 88.7%. 88.877%. Receiver operating characteristic. Let's see कितना हुआ है अपना. We're on slide 38. Okay, not like even half the way through. अच्छा, halfway से ज़्यादा हो गया थोड़ा. Let's see. Receiver operating characteristic, ROC. The receiver operating characteristic, ROC, or the ROC curve, is a graphical plot that illustrates the performance of a binary classifier system, as its discrimination threshold is varied. Threshold is not fixed, it is variable. The curve is created by plotting the true positive rate, TPR, against the false positive rate, FPR, as various threshold settings. The true positive rate is also known as sensitivity or the sensitivity index, known as D prime. In single detection and biomedical informatics, okay. Recall in machine learning, something. So they are saying the false positive rate is also known as fall out, and out can be calculated as one specificity. The ROC curve is thus sensitivity as a function followed. Something to they are saying. ना समझ लो, receiver operating characteristic or ROC curve is a graphical plot that illustrates the performance of a binary classifier system as its discrimination threshold is varied. Bro, ये तो literal रट्टा मारना पड़ेगा. Never mind. Receiver operating characteristic. Receiver operating characteristic. There are a number of methods of evaluating whether a logistic model is good model or not. One such way is sensitivity and specificity. Sensitivity and specificity are statistical measures of the performance of a binary classification test, also known as statistics as classification function. ये अपन ने उसमें देखा, there was like specificity and sensitivity के formulas. तो sensitivity over recall. ठीक है. Sensitivity upon recall, also known as the true positive rate or the recall, measures the proportion of actual positives which are correctly identified as such. The percentage of sick people who are correctly identified as having the condition, and in complementary to false negative rate. It shows how good a test is at detecting the positives. Sensitivity. Sensitivity is important. Specificity, also called the true negative rate, measures the proportion of negatives which are correctly identified as such. Example, the percentage of healthy people were correctly identified as not having the condition. And in complementary to the false positive rate. It shows how good a test is at avoiding false alarm. This one is at detecting the positive, and this is avoiding the false alarm. Precision is used to measure the precision पे आ गए वापस अपन. Precision is used to measure and calculate the success of a predicted value. Prediction is used to measure to precision. Precision is used as a measure to calculate the success of predicted values, so the values which are supposed to be successful. ठीक है. Values which are successful and were supposed to be successful को precision बोलते हैं. Precision is used when recall. Precision is used with recall the percent of relevant documents that it is returned by the search. Precision and recall साथ में यूज होता है, फिर F1 score आता है something. Two measures are sometimes used together in the F1 score, the आगे F1 score, to provide a single measurement for the system. It shows how many of the positively classified were relevant. Precision recall curve. The precision recall curve shows the trade-off between precision and recall for different threshold. The decision for the value of the threshold value is majorly affected by the values of precision and recall. Ideally, we want both precision and recall to be one, but ये possible नहीं है. तो F1 score तो insane हो जाएगा, 100% हो जाएगा. But this seldom is not the case. But this seldom is the case, okay? Obviously, because the chances of that happening are like really less. In case of a precision recall trade-off, we use the following arguments to decide upon the threshold. 1. Low precision, high recall. Low precision is basically it is not we not able to tell कि positive is actually a positive. High recall. High recall क्या था? Recall is important as a use of false negative trumps false positive. There are medical cases where it doesn't matter whether the false alarm wala, where the model predicted it to be a true positive, but it was actually a false. So it was a false negative. No, it was a true. Wait, diagram किधर है? It was a false positive. In applications where we want to reduce the number of false negatives without necessarily reducing the number of false positives, we choose a decision value which has a low value of precision or high value of recall. मतलब suppose, ठीक है, let's say you want to reduce the number of false negatives without reducing the number of false positives. False negatives क्या थे? False positive तो देखा कि अपन ने बोला कि पेशेंट बीमार है बट नहीं है. फॉल्स नेगेटिव क्या है? अपन जब बोलते हैं कि पेशेंट बीमार नहीं है पर वो एक्चुअली बीमार है, तो अपने को वो रिड्यूस करना है, फॉल्स नेगेटिव्स को रिड्यूस करना है. तो वी चूज अ डिसीजन वैल्यू विच हैज़ अ लो वैल्यू ऑफ प्रिसीजन और हाई वैल्यू ऑफ रिकॉल. प्रिसीजन कम होगा चलेगा, वी कैन डिटेक्ट मोर, बट important to maintain a good balance. We choose a decision value which has a low value of precision or high value of recall because they're inversely proportional. This makes sense. For example, in a cancer diagnosis application, we do not want any affected patient to be classified as not affected without giving much heed to if the patient if हाँ कैंसर पेशेंट है, उसका डायग्नोसिस किया. We do not want the affected patient to be classified as not affected without giving much heed to the patient being wrongfully diagnosed with cancer. This is because the absence of cancer can be detected by further medical diseases, but the presence of disease cannot be detected in a already rejected candidate. So if you detect it to be a false negative, तो सीन्स हो जाएगा ना. यू सेड कि वो बंदा हेल्दी है, उसको कैंसर नहीं है, बट वॉट इफ उसको कैंसर होता, तो टेस्ट रन करना पड़ता. तो इट इज़ फॉल्स पॉजिटिव चलेगा. इफ़ यू से कि भाई बंदे को कैंसर है चेक कर लो, बट एक्चुअली नहीं निकला, इट इज़ फाइन. बट अगर था और तूने डिटेक्ट नहीं किया तो सीन्स है. हाई प्रिसिजन लो रिकॉल. High precision low recall in applications where we want to reduce the number of false positives. False positives क्या है? False alarms, without necessarily reducing the number of false negatives. We choose a decision value which, so it is important to reduce false negative. इधर उल्टा कर रहे हैं अपन. We choose a decision value which has a high value of precision or a low value of recall. For example, if you are classifying customers whether they will react positively or negatively to a personalized advertisement, we want to be absolutely sure that the customer will react positively to the advertisement, because otherwise a negative reaction can cause a loss of potential sales for the customer. This is where we use high precision, because false negatives तो afford कर नहीं सकते इस केस में. Goodness of fit, Gini coefficient. The Gini coefficient is sometimes used in classification problems. Gini coefficient can be straight away derived from the AUC ROC number. Gini is nothing but the ratio between area between ROC curve and the diagonal line, and the area of the about, like, you guys realize the I am also reading this PPT for the first time, even I am like understanding at the same time. So here, chill kar. The Gini coefficient is sometimes used in classification problems. ठीक है, Gini coefficient is sometimes used in the classification problems. Gini coefficient can be straight away derived from AUC ROC number. AUC ROC is a number, obviously. Gini is nothing but the ratio between area between. Whoa, Gini is nothing but the ratio between area between the ROC curve and the diagonal line and the area of the above triangle. I need a diagrammatic representation of this. But Gini का basic formula is Gini is 2 into AUC minus 1. Gini, anything above 60% is a good model. Pros and cons of logistic regression. ठीक है. The logistic regression model not only acts as a classification model but also gives you probabilities. This is a big advantage over other models where they can only provide the final classification. हाँ पापा. So, the logistic regression model not only acts as a classification model but also gives you probabilities. This is a big advantage over other models where they can only provide the final classification. Oh, financial, man. This is a big advantage over models where they can only provide final classification. Knowing that an instance has 99% probability for a class compared to 51% makes a big difference. Logistic regression performs well when the data set is linearly separable. See, now ये सब समझा के तो मतलब लग नहीं रहा मेरे को. You'll have to like literally learn and write the pros and cons if asked in paper. Logistic regression not only gives a measure of how relevant a predictor coefficient size is, but also its direction of association, positive or negative. We see that the logistic regression is easier to complement, interpret, and very efficient to train. Cons. Logistic regression can suffer from. It can be explained. Wait. The logistic regression model not only acts as a classification model. So we know we use logistic regression for classification, barabar, but also gives you probabilities because we work on the basis of probabilities. So it also gives you probabilities. This is a big advantage over models where they can only provide final classification. तो एस वी एम ले लो. एस वी एम में ना सिर्फ फाइनल आउटपुट आता है कि ये क्लस्टर है, ये क्लस्टर 1 है, ये क्लस्टर 2 है. बट लॉजिस्टिक रिग्रेशन में you also have probabilities along with classification model. Knowing that an instance has 99% probability for class compared to 51% makes a difference. So when you know probability that it is 91% compared to 51% makes a big difference, obviously. Logistic regression performs well when the data set is linearly separable. Linearly separable क्या है? That is, it can be divided with using one line, one hyperplane, one something. It's a linearly divided into two parts. Logistic regression not only gives a measure of how relevant a predictor is, that is coefficient sizes, but also its direction of association, positive or negative. So it can not only predict the coefficient ka size, but it can also give us the association ka value. Is it positively associated to something or negatively associated to something? We see that logistic regression is easier to implement, interpret, and very efficient to train. It's an all-rounder. Easy to implement, easy to interpret, very efficient to train. Cons of logistic regression. Logistic regression can suffer from complete separation. If there is a feature that will perfectly separate the two classes, the logistic regression model can no longer be trained. This is because the weight for the feature would not converge. Because the optimal weight would be infinite, this is really a bit unfortunate. Because such a feature is really very useful. But you do not need machine learning if you have a simple rule that separates both classes. The problem of complete separation could be solved by introducing penalization of the weights or defining a prior probability distribution of weights. Logistic regression can suffer from complete separation. Self-explanatory. If there is a feature that would perfectly separate the two classes, the logistic regression model can no longer be trained. Let's take attribute rain. And for that attribute rain, whenever it rains, बहुत और 2-3 attributes है, but whenever it is raining, you are not going out to play. तो रेन नो हो रहा है. So there is this feature that is able to perfectly separate the two classes. जब भी रेन हो रहा है तो खेलने नहीं जा रहा है. That becomes the line. Now this is the problem. Logistic regression model can no longer be trained. Okay, this is no longer training. It is just classification. Same. It is literally hard coding. बाकी कोई भी वेरिएबल के वैल्यू से फ़र्क ही नहीं पड़ रहा है, बिकॉज नाउ द इंफॉर्मेशन गेन ऑफ दिस हैज़ बिकम 100. ठीक है, बिकॉज द ऑप्टिमल वेट वुड बी इन्फिनाइट. वही, इट इज़ सो, मतलब हमेशा बारिश हो रहा है तो खेलने नहीं जा रहा है. सो इट इज़ लाइक इन्फिनाइटली ऑप्टिमल वेट डाल दिया तूने उसके ऊपर, दैट व्हेनेवर इट रेन्स यू वोंट गो आउट टू प्ले. This is really a bit unfortunate because such a feature is really very useful. Now this is useful. Agar if I am a kid who doesn't like to play in rains, so it is a thing. Like you wouldn't play in rains. Like if there's a terrorist attack, one wouldn't go inside, right? One wouldn't to go to shopping in that mall. But then for a machine learning model, that is thoda sa it cannot train itself, because if that is the case. But you do not need machine learning if you have simple rule that separates both classes. Exactly what I'm saying. It is literally hard coding. If you have the simple rule कि बाहर बारिश हो रहा है तो खेलने मत जाओ, और बाहर बारिश नहीं हो रही तो खेलने जाओ, तो मशीन लर्निंग की ज़रूरत ही क्या है? इट इज़ लिटरली वन इफ स्टेटमेंट का काम. इफ रेन, डू नॉट प्ले, एल्स प्ले. तो उसके लिए मशीन लर्निंग यूज़ ही क्यों करना है? द प्रॉब्लम ऑफ कंप्लीट सेपरेशन कैन बी सॉल्व बाय इंट्रोड्यूसिंग penalization of the weights or defining a prior probability distribution of weights. Now you can penalize. ठीक है, if it was just raining but all the other conditions were calling out to play, तेरे friends बाहर है, your parents are at home, it is evening time, all of these are positive indications that you should go out and play. But just because it is raining you're not going out, you should penalize this prediction. ठीक है, one can play in rains, that is not a problem if all the conditions are being met. ठीक है, now moving on to the second con. Logistic regression is less prone to overfitting but can overfit in high dimensional datasets. Is less prone to overfitting. ठीक है, overfitting क्या होता है? That the model fits the data so well that it literally by hearts the data, and anything else in the training set that you provided, it is not able to understand it, and it just gives anomaly wala output, or it replicates the output of the training set. ठीक है, लॉजिस्टिक रिग्रेशन इज लेस प्रोन टू दिस. ठीक है, बट इन केसेस वेयर देयर इज हाई डिमेंशनलिटी, मतलब बहुत एट्रीब्यूट्स है, देर आर चांसेस दैट इट में ओवरफिट. ठीक है, रेगुलराइजेशन टेक्निक्स शुड बी कंसिडर्ड टू अवॉइड ओवरफिटिंग इन सच सिनेरियोज. सो अगर हाई डिमेंशनल डेटा है तो यू शुड यूज सम सॉर्ट ऑफ रेगुलराइजेशन टेक्निक्स. ठीक है, now k-nearest neighbor KNN algorithm. K-nearest neighbor is one of the simplest machine learning algorithms based on supervised learning technique. K-nearest neighbor is one of the simplest machine learning algorithms based on supervised learning technique. Again, this is also supervised. KNN algorithm assumes similarity between the new case data and available cases and put the new case into the category that is the most similar to the available category. KNN algorithm stores all the available data and classifies a new data point based on the similarity. There's कितना बाकी है अपना? 50 and we got 65. 15 slides to go. The k-nearest neighbor is one of the simplest machine learning algorithms based on supervised learning technique. KNN algorithms assumes that similarity between the new data and available data, and put the new case into the category that is the most similar to the available data. ठीक है, it finds ऐसा the closest similar data inside the previously existing database and matches it to the output. This means when the new data appears, then it can be easily classified into a well-suited category by using KNN algorithm. That is the nearest possible association that it can develop with a previously existing data set, That is what it attaches the input to. KNN algorithm can be used for regression as well as for classification, but mostly it is used for classification problems. KNN is non-parametric algorithm, which means it does not have any assumptions on underlying data. Where in the previous thing, logistic regression, it was having assumptions, it was taking probability, it was having an assumption of the underlying data. KNN doesn't give shit about the data. It is like तू सिमिलर दिखता है, तुम दोनों सेम हो और तुम्हारा आउटपुट ये है. It is literally this. It is also called a lazy learner algorithm. देखा? It is like तू तू येलो कलर का यूनिफॉर्म पहन के आया, तू भी येलो यूनिफॉर्म पहन के आया. It must be that you both belong to the same school. But it is literally doing this. It is a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the data set, and at the time of classification, it performs an action on the data set. So there's no model being trained. It literally just at the time of the input being given, um, it does that. uh, KNN algorithm at the training phase just stores the data set, and when it gets the new data, then it classifies the data into categories. That is much similar to the new data. KNN algorithm at the training phase stores the data set, and when it gets new data, then it classifies the data into category. That is much similar to the new data. So there's no pre-training happening. All of it happens when the new data is provided for it to work upon, और तभी वो decision सब लेता है और तभी वो classify करता है. Example: suppose we have an image of a creature that looks similar to a cat and dog, but we want to know either it is a cat or a dog. So for this identification, we use the KNN algorithm as it works on similarity measure. Our KNN model will find the similar features of the new data set of the cat and dog images, and based on the most similar features, it will put it into either cat or dog category. ठीक है? Why do we need a KNN algorithm? Suppose there are two categories, category A and category B, and we have a new data point x1. So this data point will lie in which of these categories? To solve this type of problem, we need a KNN algorithm, K nearest neighbor algorithm. With the help of K nearest neighbor algorithm, we can easily identify the category or class of a particular data set. Consider the below diagram. x1 x2 है, category B, category A green है, category B yellow है, new data point blue है. Now how do we define कि वो क्या है? Now because it is closest to category A, it is category A is what KNN does, and it assigns it to category A. That is how it adds new data. That is how it's training itself. KNN algorithm. Step 1: select the number of K of the neighbors clusters. Calculate the Euclidean distance of K number of neighbors. Take the K nearest neighbors as per the Euclidean distance. Among these K neighbors, count the, ये तो I guess numerical है, so we'll solve it. Among these K neighbors, count the number of data points in each category. Assign the new data points to the category for which number of the neighbors is maximum. Our model is ready. Suppose we have a new data point and we need to put it in a required category. Consider the below image. किस में जाएगा ये? I'm assuming it looks closer to a blue, so it is blue. ठीक है. Example. This is how we do it. First, we will choose the number of neighbors. So we will choose the K is 5. We chose 5 neighbors. 5 neighbors of what? This particular yellow, orange. ठीक है. And then we calculate the Euclidean distance for each of the neighbors. तो ये 5 neighbors निकाला, इन सब का Euclidean distance निकाला. By calculating the Euclidean distance, we got the nearest neighbors as 3 nearest neighbors in the category A and 2 nearest neighbors in category B. Consider the below image. As we see, the 3 nearest neighbors are from category A. Hence, the new data point must belong to category A. Oh, because it is closer to category A, it goes to category A. Say, how to select the value of K in the KNN algorithm. K ढूंढेगा कैसे? K 5 लेना था, 6 लेना है, and also how do you tell that you want to take these points? There is no particular way to determine the best value for K, So you need to try some values to find the best out of them. The most preferred value of k is 5. A very low value of k as such as k equals to 1 or k can be noisy and lead to the effect of outliers in the model. Large values for k are good, but it may be difficult sometimes. Advantages of KNN. Advantages. It is simple to implement. It is robust to the noisy training data. It can be more effective if the training data is large. Works easily on multi-class problems. Disadvantages. Always needs to determine the value of k, which may be complex sometimes. The computation cost is high because of calculating distance between the data points for all training samples in real time actually. Applications of KNN. Data pre-processing. How much more to go? 59, 65, 6 more. Applications of KNN. Data pre-processing. Datasets frequently have missing values, but the KNN algorithm can estimate for those values in a process known as missing data imputation. So, data pre-processing में data sets frequently have missing values, but KNN algorithm, because it can find the closest relative relation to the looking at the other data in set, can estimate for those values in a process known as missing data imputation. Recommendation engines using clickstream data from website. अभी अपने को recommended video आता है. Suppose you are watching a lot of cricket videos. Even the YouTube algorithm is gonna recommend cricket videos, cricket के more videos. So that is recommendation engine. Using clickstream data from websites, the KNN algorithm can be used to provide automatic recommendations to users on additional content. However, given the scaling issues with KNN, this approach may not be optimal for larger data. I mean, obviously, YouTube is not using KNN, I believe, because literal millions and billions of videos, I'm assuming, but I will not know the exact number. Never mind. More applications. Finance. It has also been used in a variety of finance and economic use cases. For example, using KNN on a credit card data can help bank assess risk of a loan to an organization or individual. It is used to determine the credit worthiness of a loan applicant. Another application is to use in stock market forecasting, currency exchange rates, trading features, and money laundering analysis. Healthcare. KNN has also application within healthcare industry, making predictions on the risk of heart attacks, prostate cancer. Pattern recognition is also one of the applications, such as text and digit classification, identifying similar handwritings and all. Working of KNN. So this is KNN numerical, which we'll do अलग से. Yeah, so that is it. Logistic regression. एक बार overview कर लेते हैं. Let's just have our overview. क्या क्या देखा? Supervised learning पता है अपने को. Types of supervised learning, classification model, regression model. What is regression? What is logistic regression? Logistic regression is example of supervised. It is used for classification. It is having binary outputs. The outputs can be of two types, three types. Output किधर गया वो? Binomial, multinomial, ordinal, ठीक है. Logistic regression. Ordinal है क्या इसमें? Ordinal is in that. Linear regression में ordinal इसमें ही है ना, कोविड वाला एग्जाम्पल. हाँ इसमें ही है. हाँ तो लीनियर, मल्टीनोमियल एंड ऑर्डिनल. बोल मम्मा. टाइम 15-20 मिनट. ठीक है. फिर इधर आता है लॉजिस्टिक रिग्रेशन. वेयर टू यूज़ कर लेते हैं इन ऑल दिस इंडस्ट्रीज, हेल्थ फाइनेंस, मार्केटिंग, फ्रॉड. लॉजिस्टिक रिग्रेशन एस कर्व फॉर्म होता है सिग्मॉइड फंक्शन यूज़ करके. 0 और 1 के बीच में वैल्यू आती है. assumptions for logistic regression. Categorical in nature. There is no collinearity between independent variables, and a fairly large data set is required. ये सब इज फाइन. लॉजिक रिग्रेशन की इक्वेशन है. टाइप ऑफ लॉजिक रिग्रेशन अपने देखा, बाइनरी, मल्टीनोमियल एंड ऑर्डिनल. Model evaluation matrix tells us how good is the fit of the model. Confusion matrix अपन ने देखा is confused when it makes it shows the ways in which a classification model is confused when it makes predictions. Then there are these true positive, false negative, true negative, and all these formulas which are used to solve the sum. I will safely skip through all of the confusion matrix का part. With this Gini coefficient, Gini का formula is 2 into AOC minus 1. Then there's pros and cons of logistic regression. तो पहले pro देख लेते हैं. Pro क्या था? It provides probability as well as classification model. ठीक है. Data set is linearly separable. वो अच्छा है उसके लिए. Logistic regression not only gives a measure of how relevant a predict, it gives us the association also of the coefficient sizes. Is it positively associated or negatively associated? Whereas the cons are uh, can no longer be trained. If there is um, if there is a feature or an attribute that perfectly separates the two classes, the model cannot be trained. Logistic regression less prone to overfitting, but can overfit in high dimensional cases where we have to use regularization to avoid. Regularization technique. K nearest neighbor is basically non-parametric, lazy learner algorithm. It does not learn. It just relates it to the nearest, uh, assumes the similarity between the new case data and available case, and puts the new case into the category that is most similar to the available data, and that is how it trains itself. Example है, similar दिख रहा है तो डाल दो उसमें. Why do we need KNN? Faster category allocation. Step क्या है? Select the number of k कितना? K is the basically neighbors जिसके साथ अपन new data को check करने वाले हैं. Calculate the Euclidean distance from those number of neighbors. Take the k nearest neighbors as per the calculated Euclidean distance. Among this k nearest neighbor, count the number of data points in each category. तो अगर सपोज 3 सबसे क्लोज आ रहा है तो तीनों में से कौन सी कैटेगरी में कितना? अगर 2 कैटेगरी 1 में तो कैटेगरी 1 में डाल दो नए डेटा को. Assign the new data point to the category for which the number of the neighbor is maximum. Our model is ready. Example तो we know. फिर क्या था? How to select the value of k. Value of k is usually preferred phi. Lower value can lead to noisy and lead to effect of outliers in model. Large value is good, but it may sometimes be difficult. Advantages: simple to implement, robust to the noisy training data, more effective on a larger data set, works easily on multi-class problems. Disadvantages: determining k can be complex, computation cost calculating the distance can be high for all the data points. Obviously, applications: data pre-processing where there are missing values, recommendation engines where we have to recommend users on the clickstream data पे recommendations चाहिए तो. But if the data set is too large, then KNN should preferably not be used. Finance में to detect currency exchange rates, stock market forecasting, trading futures, money laundering analysis. Healthcare में to predict cancer, tumor, whatever you want to predict. COVID, pattern recognition. KNN can be used because it works on similarity concept. You can identify similar handwriting, similar text, similar digit classification, similar type of text, and then there's numerical, which we'll see.